Okay, grade 9, here we are, the very first lesson of your last science unit of grade 9 science. So you've done 6 units so far. It's been quite the year, and this is your 7th and last unit. After these 10 lessons, review day and test, then of course your final exam, you will have completed the first year of high school science. So you're so close, guys. Keep up. I know it's hard with quarantine, but you can do it. Find the energy, dig deep, because we're going to be doing lots of stuff for this unit, and it's really important to build for next year, like every unit, but this chemistry is one that really builds directly one unit upon the next. So we're going to start, our first lesson today is setting up our notebook for our phenomenon, that kind of stuff for our unit, but also reminding ourselves of some of the important things of our first chemistry unit. So we did chemistry back in August and September. It's been a while. And that was a choice that was made because we wanted to make sure we came back and reviewed. Instead of doing all the chemistry at once and then you forgetting it until grade 10, we wanted to split it up so you can hopefully be more likely to convert this chemistry knowledge from short-term memory into long-term memory. Okay, so you're going to first start by starting your notebook, and remember, if your notebook is almost done, if you have less than 20-25 pages left in your notebook, then start a new notebook. Okay, you don't want to start your notebook halfway through a unit, it's really annoying. So make sure you have a notebook, and our unit title is The Name's Bond, Chemical Bond. Now, I cannot do that with a very good accent at all. Hopefully Mr. Byatt will do it for us at some point because he has a British accent and I'm sure it'd be much better than what I just did. But that's our unit title. And then we have table of contents page, of course, and to number the pages of your notebook like we always do every unit. You guys should be pretty familiar with this whole process now. So here's your unit title page from May 5th until June something when we finish. Table of contents, we have our title, our unit title page, we have a table of contents page, our phenomenon is cyanotype, and the chemical bonds, big ideas. So here is your phenomenon page. How can chemical reactions be used, or what kind of applications do we have chemical reactions? So you're going to start today with I notice, wonder, and what I first think when you watch the phenomenon video, and then we'll come back and do these at the very end of our last unit. So here's the phenomenon. We're not going to watch it here because you won't have any sound, but I will link it in the Schoology post. But it's about cyanotype, which is a type of photography development that uses a lot of interesting chemical reactions. And you'll be doing it in art. You're supposed to be doing it in art now, but of course, with the way art is happening right now, every course is happening with virtual school, that's not really possible, but you will be doing it next year in art class for sure. I spoke to Miss B today and we just discussed that we're still kind of aligning our science and art that way. So you'll watch the video about this and then write your reflections. Okay, so after you've watched it, come back and fill in these two parts, 4 or 5 sentences or 4 and 5 bullet points minimum here for both, okay? Okay, and then we have our big ideas page, chemical bonds, big ideas. There will be 4 of them, like there's for every unit. And those, of course, are the big important things that will definitely be showing up on your unit test, on your final exam, all that kind of stuff. Okay, and so for today's template, I'm trying not to make it too prescriptive because you need to write down what you need to review. And the level of detail of notes you take today will be somewhat up to you. You need to take notes on the important ideas. If you're somebody who remembers chemistry fairly well, your notes might be less detailed than somebody who can't remember anything. Either one is fine, as long as you have notes about this. I'm going to make you do a couple drawings, and I just divided the note template into 2 parts, reviewing atoms and reviewing octets and reactivity. So we talked about those 2 things today from our previous unit we did in August and September. If you have your notes from that, go back and look at them. Look at them, it's really helpful for you to have that as a reference in this unit, as a couple of drawings. If you know you're going to take a lot of notes, you might want to not divide the page in half until you see how much you write down for reviewing atoms. Okay? So, first thing, you got to find your periodic table. We did those giant foldable periodic tables. Hopefully, I told you guys to hold on to them, at least told my class that. If you don't have yours anymore, then you need to print a periodic table, or if you don't have a printer at home, you need to draw one, or at least get one like for your desktop. You need to have that as a reference. And so reminder, whatever periodic table you end up using, this information should be on it. You should have the elements. So the purple elements here are gaseous. their states. The green ones are liquids and the rest are solids. So I had students in my class leave this, don't color it into the solids at all, write the liquids with blue kind of outlines and the gas with red outlines. You should also for sure be indicating somehow the blue ones are all your metals and the yellow are nonmetals, and this hydrogen here should be yellow. It's a nonmetal as well. And then all the different families and groups should know those as well. We're going to be learning about chemical reactions in this unit, so you need to be able to identify what if the element is a metal or non-metal and what family it's in, because they have different ways to react based on their properties. So you're going to make sure you include a picture of your periodic table in your upload for today's lesson. So if you have your periodic table, that's great. Pull it out, snap a picture, put that in your notes so I know you have it. If you don't have it, you can print one, color it in. You can find a digital one and save it to your desktop or somewhere where you can see it really easily. But you just show me that you have a periodic table ready to go because we'll be using it next class. Okay, I asked you guys in the first unit to memorize the names and symbols of the first 20 elements, just because it makes it much easier to talk about chemical reactions than having to look things up all the time. Do you still remember them? Are they still in your memory, or have you forgotten them? If you've forgotten them, they're probably still in your brain somewhere, and a little bit of review will help bring them back up, and I recommend you take some time and look over them again, because when we start doing chemical reactions, I'm not going to stop and explain what every element is, right? So the more you're familiar with them, and if I just say H2O, you already know that's hydrogen, 2 hydrogens and an oxygen, and H3 is nitrogen and 3 hydrogens, that kind of stuff, you know that immediately. It'll be easier for you with the more complicated things we'll be doing in this unit. So it's worth taking some time now. This week isn't too heavy for science, and reviewing that a little bit. Okay, so this is the first part you may want to take notes on. Let's remember the difference between atomic number, atomic mass, and mass number. These are confusing terms. They sound almost the same, but they're different things. So first things first, the atomic number. Atomic number here in the periodic table, usually above, it's always a whole number, and it's the number of protons in that particular element. So carbon always has 6 protons. That's what makes it carbon. So these are all different carbons. They all have 6 protons. So 6 protons, 6 protons, 6 protons. Every single one has 6 because that's what makes it carbon. So atomic number is always a whole number, and it's always the number of protons in that element. Okay, atomic mass is a decimal. Here it is for carbon, and it's unique to each element. And we actually practice how to calculate atomic mass in our very first unit. So if you look back in your notes, you remember how that works. And if you remember, it's a weighted average. So it's the average number of protons plus neutrons in an atom, but it's weighted, so the more common elements have a bigger impact on that average. So we practice how to do this, and you can look back in your notes for the reminder. But here we have 3 different versions of carbon, 3 different isotopes of carbon, and they all have different numbers of neutrons. So they all have a different number here, a total, called the mass number, and that's going to be averaged out to make this atomic mass. Now it's really close to 12 because carbon 12 with 6 protons and 6 neutrons is the most common element. These elements are less common, so that's why it's not. Like if you just took these 3, add them up and divide it by 3, you'd get 13. But it's 12.011 because carbon 12 is much, much more common than carbon 13 and carbon 14. Okay, remember those different versions of an element that have the same number of protons, of course, it's the same element, but different numbers of neutrons. Those are isotopes. So here's 3 isotopes of carbon. Okay, now the mass number, the last type of number about an atom, is the number of protons plus number of neutrons. So it's a whole number, but it's specific to a certain atom, so you can't find it in the periodic table, because the periodic table tells you the general pattern for all atoms of that element, whereas this is specific to each one. So all these 3 different carbons all have a different mass number. So mass number here is 12. Mass number here is 6 plus 7, 13. Mass number here is 6 plus 8, 14. So they're all different, and that's what's not in the periodic table. So make sure in your review notes you define as a minimum atomic number, atomic mass, and mass number. You need to, those are confusingly similar terms. You need to review them so you don't get them missed Oh my gosh, don't get them mixed up. There we go, I can talk. Okay, let's review the structure of the atom. So the subatomic particles are 3 particles that are smaller than an atom. Can you remember what they are? Can you see them on the screen? That's right, guys, it's protons, electrons, and neutrons. So where are they? Well, protons and neutrons are in the nucleus, where the center part here is called the nucleus of the atom, and the electrons are in these orbitals around the nucleus. Since they're called electron shells, I call them orbitals, same thing. And they're orbiting, moving around the nucleus. Do you remember the charges of these particles and their relative masses? Well, protons are positive. Their relative mass of 1, and the symbol is a little p. Neutrons have a neutral charge, relative mass of 1, and the symbol is in small n. Electrons are negative. Their relative mass is 1,836th the mass of a proton or a neutron. Very, very light compared to how much a proton or neutron weighs, and their symbol is E, the little negative sign. I usually write my proton P with a little positive sign, showing the charge. So pause for a science joke here. Okay, I have to remember it. Okay, the neutron goes up to a bar and orders a drink. And he asks the bartender, okay, well, how much does that cost? And the bartender says, for you, no charge. But that's right, it's funny because it's a neutron, he's no charge, he gets no charge for the drink. I'm hilarious, I know. Okay, next thing to remember are Bohr diagrams. So do you remember how to make these? You're going to have to draw them in this unit, and next lesson you're going to have to draw them. So if you don't remember, I'm going to go through it now, but maybe some more practice in your notes from the previous unit. So to do this, you have to have the number of protons, neutrons, and electrons. To figure that out first, using the atomic number and the mass number, I will have to give you the mass number to do that. So you write that down next to symbols. So protons, 13 P plus in aluminum. Neutrons are 14 N0 in this particular isotope of aluminum. There it is in the nucleus. Okay, so protons and neutrons, first place to start. The next thing you're going to do is do the electrons, and electrons are a little bit harder, right? We have to distribute them around the different orbitals. So you figured how many there are, and it should be the same number as there is protons in a neutral atom. And the first orbital has up to 2 electrons only. The second orbital and all the rest of them have up to 8. So 2, 4, 6, 8. And remember, you have to fill one orbital before you go to the next one. So if we have 13 electrons in aluminum, because it has a neutral charge in this atom of aluminum, so 13 protons, 13 electrons, then first orbital is going to have 2, which means I still have to put 11 electrons out. My second orbital will have 8, which means I still have 3 electrons to put out, and my third orbital is going to have 3. There we go. Okay, so you need to draw a Bohr diagram like this one in your notes for today to remind yourself how to do it. Write down the rules so you don't forget the rules because you're going to be drawing them next class. Okay, here's some practice ones. You can draw these practice ones instead if you want. So here's sulfur. Touch yourself, draw it. So hopefully you get something like this. We have sulfur with 16 protons and 16 neutrons, because I have my mass number here on the top, atomic number on the bottom. So 32 minus 16 is 16, so I know I have 16 and 16 here in the middle. And I'm going to have 16 electrons, which means 2 in the first orbital, 8 in the next one, that gives me 10, and 6 in the third one to get 16 total. One more time. Here I've got potassium. Do some mathing and draw it, please. Okay, so I've got, did you get this? 19 protons, total numbers down here, 20 neutrons, 39 minus 19 gives me that 20, and then I'm going to also have 19 protons, so 2 here, 2, 4, 6, 8 second orbital, that gives me 10, 8 more on the third orbital gives me 18, plus 1 more on the next orbital gives me 19 total electrons. So again, if you don't remember how to do these, or it's not familiar to you at all, then you need to go back and review this. Okay, now let's talk about the octet rule. This is the second main set of information you need to review before we get into our next unit. So who remembers what the octet rule is? So the octet rule is talking about the tendency of electrons to want to have a full valence orbital, or that outer orbital of electrons. Here's the valence electrons are the ones in the last orbital, and all atoms want to be stable, and to be stable they have to have a full octet, or a full outer orbital. We call it the octet because most of the time, for everything except hydrogen and helium, having 8 electrons makes it full. So that is directly related to the reactivity of elements. Do you remember which elements are the most and least reactive? So a hint, the closer an element is to having a full valence or a full octet, the more reactive it's going to be. The more it wants to be stable, the more it's going to be reactive to become stable, if you can think of atoms as having a thought process. So if that's the case, which two groups are the most reactive and which are the least? Well, the most reactive are going to be the ones, so the noble gases here have a full octet, so they're the least reactive. They're not going to react. That's why the name noble gases. They're very kind of beyond the others. They don't need to react. They've got what they need for electrons. So that means the closer they are to the noble gases, the more reactive elements are going to be. So this group here, the halogens, are 1 electron short of having a full octet. So they're very reactive. And the other extreme here, over here, the alkali metals, they have 1 electron only in their valence. They can get rid of that really easily, and so really close to being a full octet as well. And if you remember, the periodic table is meant to be thought of in 3 dimensions as kind of a circle. So this column should be next to this column. Okay, so our most reactive and least reactive. So make sure you draw something about valence electrons in your notes from today. So the most reactive families are going to be the alkali metals and the halogens, and the least reactive are the noble gases. So what is a half electron configuration, but where the electrons are? Well, noble gases are stable because they have a full octet. They are completely full. Helium has 2 valence electrons, but only 1 orbital, so that means it's full. The rest of them all have 8. They are full, they are happy, they're very stable. And alkali metals have 1 electron only, 1 valence electron only, whereas halogens have 7. They're close. So both of them are really close to being full, so they're very, very reactive because they want to be full. Okay? All right, so that's the end of today's kind of review cap-up of chemistry stuff that we did back in August and September. Make sure you take notes based on your own needs, but you have to take some notes, okay? You can't leave it blank and just say, oh, I knew everything, I remember everything, I'm a chemistry genius. Wonderful for you if you are a chemistry genius, but you still need to take some notes, okay? So here's what you need to upload for homework to Schoology today. It's a lot of pages, so try and do it as one scan with multiple pages in it instead of a million little uploads. It makes my life and Mr. Barnes' life much easier if you do it that way. So we have the title page, table of contents, phenomenon page with your reflections, the big ideas page, your review notes page, and your photo of your periodic table. Show me that you have a periodic table and you're ready for the next lesson because we're starting with bonding next class. Okay guys, hope everyone's home safe and taking care of themselves, and hopefully chemistry starts coming back to you and you dream about the periodic table tonight.